Hello dear students, welcome to Royal Palace PU College online classes. Dear students, in the previous session we have discussed about the differentiation of lot of functions like logarithm, exponential, okay, implicit, explicit, inverse trigonometric, okay. These are all things we have discussed in the previous class. Now today in this class we shall extend our differentiation topic. So today we shall start with the mean value theorems. So in this mean value theorem there are two types. The first one is Rolle's theorem and the second will be Lagrange's mean value theorem. First one is Rolle's theorem. So now before starting with this Rolle's theorem, let us start with the definition of the Rolle's theorem. That is a very important thing. Definition is the must and should required here. So here everything depends on this particular definition only. Okay. So in the examination fixed one problem will be there, okay, in the examination, that is on Rolle's theorem or either on mean value theorem. Lagrange's mean value theorem, it is also known as mean value theorem also. Now definition, how it is a definition? Let f of x, let y is equal to f of x be a function defined on interval a comma b, defined on the interval a comma b, such that, okay, I will take the symbol here, such that the first point is f of x, okay, is continuous, f of x is continuous on the closed interval a comma b. Here it is compulsory closed only, that is very important point. Then the second point is, okay, f of x is a differentiable in open interval a comma b. Here fixed compulsory we have to make use of here open interval only. I will just tell the geometrical interpretation of it also. Okay, either geometrical interpretation hang irtade annodu adu kuda discussion ಮಾಡೋಣ. Okay, third point f of a is equal to f of b. Okay, f of a is equal to f of b. All these 3 points should be satisfied. Okay, so what is the first point here? F of x is continuous. Continuous ಅಂದ್ರೆ ಏನು? ಆ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಗ್ಯಾಪ್ ಆಗಲಿ ಬ್ರೇಕ್ ಆಗಲಿ ಇರಬಾರದು. Next, f of x is a differentiable. Differentiable ಅಂದ್ರೆ ಏನು? We can draw the tangent at every point except at the end points ಅಂತ ಇರುತ್ತಿಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರ ಏನಂತ ಇಲ್ಲಿ ಕ್ಲೋಸ್ ಇಂಟರ್ವಲ್ ತಗೊಂಡಿಲ್ಲ, ಓಪನ್ ಇಂಟರ್ವಲ್ ತಗೊಂಡಿದ್ದಾರೆ ಇಲ್ಲಿ. Okay, one thing. Then and also f of a should be equal to f of b. Then if all these three conditions satisfies, then there exist at least one point C between A and B such that f dash of C equal to 0. So that means what here is at least one point C, okay, see here belongs to, that is C belongs to A comma B here, that means it is between A and B, not the end interval, end points. Okay, here at least one point C, okay, comma, such that C belongs to A comma B and f dash of C is equal to 0. This is our required result. Then we say that this function f of x satisfies the Rolle's theorem. Then f of x satisfies Rolle's theorem. So dear students, in the examination one fixed question will be there either on Rolle's theorem or either on Cauchy's mean value theorem. Both the problems are very simple only. The main thing or the main motto here is we must and should require the definitions here. Both the definition is the must, okay, and we require that. Okay, if you had understood the definition properly and clearly, then the problems are over only. Okay, now let us observe here geometrical meaning, geometrical interpretation. Now what it is, geometrical meaning ಅಂತ ಅರ್ಥದಲ್ಲಿ. ಈಗ ನಾವು ಒಂದು ಫಂಕ್ಷನ್ ತಗೊಂಡಿವಿ ಯಾವುದಲ್ಲಿ y of x, okay, and I will draw that graph. Okay, I will draw the graph that is y is equal to f of x. Now here this point actually is x is equal to a, and let us take this point as x is equal to b here. Now here what it is, this is nothing but our function, that is f of x here, graph of the function y is equal to f of x. Now here what first point is, f of x is continuous in closed interval a comma b. A comma b ಅಂದ್ರೆ ಇಲ್ಲಿ ಹಿಡ್ಕೊಂಡು ಇಲ್ಲಿ ತರಲಿಕ್ಕೆ, ಓಕೆ, ಈ ಪಾಯಿಂಟ್ ಹಿಡ್ಕೊಂಡು ಈ ಪಾಯಿಂಟ್ ವರೆಗೆ ಫಂಕ್ಷನ್ ಏನೈತಿ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿರಬೇಕು. ಕಂಟಿನ್ಯೂಸ್ ಅಂದ್ರೆ ಏನು, ವಿ ಶುಡ್ ನಾಟ್ ಹ್ಯಾವ್ ಎನಿ ಗ್ಯಾಪ್, ಬ್ರೇಕ್ ಆರ್ ಕಟ್ಸ್, ವಿ ಶುಡ್ ನಾಟ್ ಹ್ಯಾವ್ ದ್ಯಾಟ್ ಥಿಂಗ್. ಒಂದೇದು. ಓಕೆ, ಸೆಕೆಂಡ್ ಥಿಂಗ್ ಅಂದರೆ ಏನಪ್ಪ ಅಂದರೆ ಇಲ್ಲಿ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಡಿಫರೆನ್ಷಿಯಬಲ್ ಇನ್ ಎ ಕಾಮ ಬಿ. ದಟ್ ಈಸ್ ಹಿಯರ್ ವಿ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಓಪನ್ ಇಂಟರ್ವಲ್ ಎ ಕಾಮ ಬಿ. ದಟ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್. ಏನಾಗುತ್ತಪ್ಪ ಅಂದರೆ ಈಗ ನಾವು ವಿ ಹ್ಯಾವ್ ಟು ಅಬ್ಸರ್ವ್ ದಟ್ ಹಿಯರ್ ಇಸ್ here, that is differentiable means what, here we can draw the, that is we are having a smooth curve in such a manner that we can draw the tangents. Here we can observe that we can draw the tangents at each and every point here. At each and every point I can draw the tangent. But what happens at the end point? I can't draw the tangent. Why? Because it's an ending point here. Okay, it's an ending point and here we can't draw the tangent here. Therefore, for that particular specific manner, what he has said is f of x is differentiable in, okay, open interval a comma b. ಅಂದ್ರೇನು ಓಪನ್ ಇಂಟರ್ವಲ್ ಅಂದ್ರೇನು, ಈ ಎಂಡ್ ಪಾಯಿಂಟ್ಸ್ ಮೇಲೆ ಏನದ ಇಲ್ಲಿ ಟ್ಯಾಂಜೆಂಟ್ ನ ಡ್ರಾ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಓಕೆ, ಐ ಕ್ಯಾನ್ ರೈಟ್ ದ ಸ್ಲೋಪ್ ಆಫ್ ದ ಟ್ಯಾಂಜೆಂಟ್ ಹಿಯರ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಥಿಂಗ್, ದೆನ್ ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ at least one point c such that c belongs to a comma b such that f dash of c equal to 0. ಇದರ ಮೀನಿಂಗ್ ಏನಪ್ಪಾ ಅಂದರೆ there exists at least one point. Okay, there exists at least one point p between this is our f of a and this is our point f of b here. So here this particular point will be a comma f of a and here this particular point will be b comma f of b here. F of b here, this particular point is b comma f of d and here a comma f of a. Here we have to observe that between a and b, that is from right from a to b, there exists one point p. Okay, there exists one point p such that, okay, let us draw here, this is nothing but here, such that here this is the point x equal to c. One point c between a and b such that this particular f dash of c means it is nothing but here the derivative. This derivative will be 0. Will be 0 means what it is, this particular tangent, okay, at a point p it is parallel to our x axis ಅಂತ ಅರ್ಥದಲ್ಲಿ. Very very simple. F dash of c equal to 0 na ಈ tangent ಏನದ tangent around the okay, point p it is parallel to x axis ಅಂತ ಅರ್ಥದಲ್ಲಿ. Very very simple meaning. ಇದೇನಪ್ಪ ಅಂದರೆ ನಮ್ಮದು geometrical meaning ಆಗುತ್ತೆ. ಓಕೆ, ಕಂಟಿನ್ಯೂಸ್ ಅಂದ್ರೇನು, we should not have any gap, break or cuts. Differentiable ಅಂದ್ರೇನು, we can draw the tangent at each and every point except the end points. End points ಮೇಲೆ tangent draw ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. That's why what he is telling is open interval a comma b here. The first thing. Then the last thing is, then there exists point c between a and b, okay, such that here c lies between a and b such that f dash of c equal to 0. F dash of c is equal to 0 ಅಂದ್ರೆ ಅರ್ಥ ಏನು? So here x is equal to c means, so this is our f of c value. Okay, so here this particular at the point p, whatever the tangent we are drawing here, that particular tangent is parallel to the x axis ಅಂತ ಅರ್ಥದಲ್ಲಿ. Okay, dear students, it is a very very simple concept related to our, okay, that is Rolle's theorem. Now let us look on to some of the examples related to our Rolle's theorem. Dear students, the problems are very very simple. Just one thing is, you should understand the definition, that's all. Now let us look on to the problems. The first one, the first problem is verify Rolle's theorem. Verify Rolle's theorem. So what we have for the following functions. The first one is f of x equal to x square minus 6x plus 8 in the closed interval 2 comma 4. In the closed interval 2 comma 4. Let us observe this particular definition problem. Now what is asking? Verify Rolle's theorem. So one we have to understand here is whenever the function is a polynomial, okay, all the polynomial functions are always continuous only. In that, but in the given interval, it is continuous. All polynomial functions are continuous. So here, since f of x is a polynomial function, therefore f of x equal to x square minus 6x plus 8 is continuous. It is very important, continuous in closed interval 2 comma 4. So this is very important thing. If you are doing mistake here, that means instead of closed, if you are writing here open, it is absolutely wrong. One more thing, closed as well as open interval. What do you mean by that? For example, closed interval a comma b. X belongs to closed interval a comma b means here a less than equal to x less than equal to b. That means here x can take all the values between a and b, including the end points. End points hidukondu enada idar nadu ella values na togottada, where x belongs to real numbers here. And also x belongs to here open interval. Now what do you mean by open interval? That implies here a less than x less than b. That means here x can take all the real numbers between a and b, but not the end points here. Between a and b, but not the end points. That is our specific meaning behind this open and closed here. Now here, that is very important. That's why I had given the geometrical interpretation of it. Okay, in that continuous means the graph should not have any cuts break. That's why the first and last values are included here. Also f of x equal to x square minus 6x plus 8 is differentiable. Okay, differentiable, that is f dash of x equal to, we have 2x minus 6. Okay, we are having f dash of x equal to 2x minus 6 here. In what it is, in the open interval 2 comma 4. That is very important to write. You should always mention here it is a differentiable in open interval 2 comma 4. You should not have any right here closed interval. Why? Because differentiable means we are able to find out the slope of the tangent. Slope of the tangent means what? Here we can draw the tangent at each and every point except the 2 and 4, first and last value. Okay, that is the first thing. Then the third point, what is the definition here? F of x is continuous, f of x is differentiable, f of a equal to f of b here. Okay, the third point is f of a equal to f of b. That implies, so here we can take it as first point, then second point, then third point. So here third point means here, what is a here? This is nothing but our a and b here. Okay, here given f of x equal to x square plus 6x plus 8, x square plus 6x plus 8 at x equal to 2 and x equal to 4. Let us observe the values here. So now what we get here? What values we are getting? Let us observe here. That is nothing but here f of 2. What is f of 2 value? So now here f of 2 I will substitute 2 square plus 6x plus 8, that is 2 square plus 6 into 2, 2 plus 8 here. Here it is minus sign, friends. Here dear students, it is minus sign here, minus 8, which is equal to, we can observe that 2 2s are 4, minus 12 plus 8. The value will be minus 8 plus 8, the value will be 0 here. That is first point. Also f of 4 equal to 4 square minus 6 into 4 plus 8. The value is 4 4s are 16 minus 24 plus 8. Now what is the value here? 16 minus 24, minus 4, that is nothing but minus 8 plus 8, the value will be 0. So therefore what we observe that f of 2 equal to f of 4, okay, and the value is equal to 0. The last very important thing, if all these three conditions satisfies, there exists at least one point C between A and B. Between A and B means what? Between 2 and 4, such that f dash of C equal to 0, and that particular C value we require to find here. Now here then there exists at least one point C belongs to, here I have to write open interval only. If you are writing closed interval, then it is absolutely wrong here. You will lose unnecessarily, 1 marks here. Between 2, 4 such that f dash of C equal to 0. Now what do you mean by this f dash of x here? F dash of x means what is the value here? 2x minus x. Instead of this x, I will put here C here. That is nothing but here 2c minus 6 equal to 0. That implies here 2c equal to, that implies c equal to, the value will be 3 here. Now c equal to, that implies c equal to 3, okay, 3, that whether it belongs to 2, 4 or not. Observe here, we can observe that there exists at least one point C belongs to 2, 4 such that f dash of C equal to 0, C equal to 3 we got, and that 3 belongs to 2 and 4, belongs to 2 and 4. That means 3 value is between 2 and 4. Hence, what we can say here is, okay, the last point is, hence f of x, verifies, or Rolle's theorem is verified, verifies Rolle's theorem. Hence, Rolle's theorem is verified. That is the required result. Okay, dear students, it is a very simple example related to our Rolle's theorem. Okay, dear students, now let us continue with the problems related to Rolle's theorem. So before starting that, please pause the video to note it down. Hello dear students, now let us start with the next problem. So here in this next problem, we can observe that it is also an polynomial function. Here f of x is an polynomial function. Okay, so what we can say is, therefore f of x is continuous function in, we can write the interval -4, 2. If you are writing compulsory, we have to write the interval, and very specifically we have to write here closed only. The second one is f of x is differentiable, okay, that is a differentiable in, that is closed interval, that is open interval -4, 2. So here we have to observe that always the differentiable, it will be in the open interval only, and here f dash of x, what is the f dash of x value here? That is nothing but here x square differentiation will be 2x plus 8. This you have to write here. The third step what it is, that means here we have to find f of a equal to f of b. Okay, f of x equal to x square plus 2x minus 8 at x equal to -4 and 2. Now what is the value? That is f of -4. F of -4 equal to, I will substitute the value, -4 square 16, then 4 2s are 8, -8 -8. So what we have to observe is 16 minus 16, the value will be 0. Also f of 2 equal to, I will substitute 2 here, 2 square is 4 plus 2 into 2 4 minus 8, again the value will be 0. So therefore what we can observe here is f of -4 equal to f of 2. So that is our third condition, it satisfies. Now then there exists at least one point C belongs to, that is here the interval I have to write. What is the interval here? -4, 2, such that f dash of C equal to 0. That means here f dash of x already we have taken. Okay, in the place of x here I will substitute here C. That means 2c minus 8 equal to 0. That implies C equal to 4 here, and it belongs to, here we can observe that -2, okay dear students. So here x square differentiation will be one thing, x square differentiation is 2x differentiation, students, here it is 2 here, I had made a mistake here. That means 2c here, 2c plus 2 it is, plus 2, and here that is nothing but -2 divided by 2, that is value will be -1, and here we can observe that minus 1, it belongs to the minus 4 comma 2 here. That is, z belongs to minus 4 comma 2. Here f dash of x differentiation is x square is 2x, 2x is 2. 8 differentiation will be 0 here. Here f dash of c equal to 0 means in the place of x, okay, you have to substitute here c here. That's all. Now here such that verifies your Rolle's theorem. Therefore Rolle's theorem is verified. A very simple and easy concept. Dear students, now let us move on with the next problem. Third one, f of x equal to x square minus 1 in 2 comma 1 comma 2 in 1 comma 2. Now here 1 comma 2 means here function itself is a polynomial, it is a continuous only. F of x is a polynomial function. Hence, okay, that is f of x is a continuous in 1 comma 2, continuous on re-entry, in re-entry. Then the second one, then f of x is a differentiable in, that is 1 comma 2. That means what is the f dash of x value here? F dash of x value, x square differentiation will be 2x. This is the second point. The third point is here f of a equal to f of b. Okay, third point is f of x equal to x square minus 1 at x equal to 1 and 2. That means f of 1 value, what we get? 1 minus 1, it is 0, and f of 2 value, that is 2 2s are 4, 4 minus 1, the value will be 3. That means we can observe that f of 1 is not equal to f of 2. That means the third condition, that is f of a is not equal to f of b, and that violates the conditions of the Rolle's theorem. ಈ Rolle's theorem find out ಮಾಡಲಿಕ್ಕೆ 3 ಕಂಡೀಷನ್ ಅದಾವ. ಯಾವುದು? ಕಂಟಿನ್ಯೂಸ್ ಇರಬೇಕು, ಡಿಫರೆನ್ಷಿಯಬಲ್ ಇರಬೇಕು, ಆಮೇಲೆ ಇನ್ನೊಂದು ಏನಪ್ಪಾ ಅಂದ್ರೆ ಇಲ್ಲಿ f of a equal to f of b ಇರಬೇಕು. Now here, since it violates our definition, that is since f of a is not equal to f of b, therefore the function f of x does not verify the Rolle's theorem. Okay, we can't use the Rolle's theorem. Okay, Rolle's theorem not verified. Therefore theorem not applicable. Or we can't verify the Rolle's theorem. That is a required result. Dear students, some of the function, what happens, like the functions like here, that is greatest integer function. This greatest integer function, it is not continuous only. For example, in the interval, that is x belongs to here 1 comma 5 it is. Here to 1 comma 5 means greatest integer function means at every point 2, 3, 4, okay, and 5. Here this function, greatest integer function, will be discontinuous only. Okay, that is here the function will be of this kind here. Okay, here we can observe that at each and every points, integer points, the function is discontinuous. Therefore here greatest integer function in 1 to 5 or 1 to 4, 1 to 3, okay, not between 1 and 2 high here, not between the specific two integers, but leaving 2 or 3, that is 1 to 5, minus 2 to minus 1. Okay, these all things are not verifiable. Okay, we can't verify it, or Rolle's theorem is not applicable here. Why? Because it is not at all continuous only. Okay, dear students, that is enough for this particular class. In the next session, we shall start with our mean value theorem or the Lagrange's mean value theorem. Thank you.